Hey everyone, this is Derek, and in this video we're going to look at graphing systems of inequalities this time. So now we got kind of two different graphs going on, and what we'll do is, like we did in the last video, we'll graph the line, shade the solution set. But now we're going to have a second one, we're going to shade that solution set, and then wherever they overlap, that's the solution to the system. So the same idea as when we had just linear equations and we looked at the point of intersection to solve. This is like that, but with whole solution sets instead of just a single point. So our first task is to get things graphed. So I'm going to graph this one in black. You can make tables on any of these if you want. I'm going to use slope and intercept just because I think that's a lot easier, and I encourage you to be comfortable with that. And if not, come down here and put in 0 and then put in 3 and you'll get the same exact stuff. So here I'm going to start off, my y-intercept is 2. My slope is -1/3, so that means I'm going to run 3 and it's negative, so I'm going to drop 1. And once I have that, I usually make a couple more points to help me try to draw something that sort of looks like a straight line. And this one is going to be a dashed line. And then it can get really messy in terms of the shading. So here, let me test 0, 0, and figure out which way we're going. So 0 is greater than, that would be 0 is 2, 0 is not greater than 2. So that is false. And so that means this would be shaded. I'm just gonna use a couple little arrows so that I don't make a big giant mess, because you'll see why in a sec. I'm gonna do this one in red. So then we got, we're gonna start on -1. And then our slope is 2, so we go over 1, up 2, over 1, up 2, and we just keep doing that. That's got equals on it, so this time I'm drawing a solid line. About there. And if I try 0, 0, I have 0 is less than or equal to -1. So 0 is less than -1. Nope. So that is also false. So this point fails, so that means we're on the other side of the line. So now if we think about kind of what would be shaded, the black one is shaded above, the red one is shaded to the right, and so this quadrant right over here, that's where they would both be shaded, because the black one was doing this and then the red one was doing that. So this little quadrant up here, that would be our solution set for that system. Okay, these next two are basically the same idea. They happen to be in standard form. Intercepts are definitely the easiest way to graph these. We're also going to see this new little bit down here. X is greater than or equal to 0, y is greater than or equal to 0. So remember, x greater than or equal to 0 is going to be a vertical line. And it's the y-axis, which is counterintuitive, but it is. And if the x's are greater than 0, that means I'm going this way, right? On my x's, I have to stay in the positive direction. If my y's are greater than 0, then that means I'm going that way. My y's are going to be positive. So what these two do together is they put you in the first quadrant. So they put you in quadrant 1 in the graph. So we're always going to have, when we have those conditions, a boundary here and a boundary here, keeping us up in the positive quadrant. So with that, let's try to get these other two graphed. So we got this first one, I'll do this one in black, x, y. So if x is 0, right, y would be 9. It looks terrible, it's actually really easy. If y is 0, 9 goes into 45, surprise, 5 times. So when x is 0, y is 9, that's right there. And then when x is 5, y is 0. So this will probably not be that straight a line, but something like that. And this one is a greater than. So if I put in 0, 0, 0 is not going to be greater than 45. So that means when we have the greater thans, they're going to be these kind that go out this way. When we have the less thans, they're going to be the kind of fenced in kind here. So right now we got this one going that way. I'll do this one in red. So if x is 0, y is 4. And if y is 0, x would have to be 7. So when x is 0, y is 4 and 7. And so again with the greater than, so it'd be going out that way. So what that means is our solution set is going to stay on the positive side of x. It has to stay kind of, think of it as maybe above the black line and the red line. So here the red and the black, the black one was higher, so it's staying above that. Here it has to stay above the red. And it still has to stay above that. So our solution set would be everything from there out in the first quadrant. And then this last one's very similar. It's just going to be a less than, so we'll see it's, this one's called unbounded. This one will be what's called bounded, in that you could draw a circle around it. So if we do x, y, so hopefully you're seeing the pattern to, if x is 0, I'm just going 6 goes into 42 7 times. So when x is 0, that's gone. This is 7. Likewise, if y is 0, 7 goes into 42 6 times. And so x0, y 7, and 6. And this one is a less than, so that would be shading inwards. Do that one in red. So if x is 0, y is 2, and when y is 0, x is 9. 2 and then 9, 0. So something like that. And then we still have these conditions that we have to stay in the first quadrant. So that's going to keep us here and going this way. So what's going to turn out to be called the feasibility region, the next section is right in there. So that little chunk will be our solution.